Inequalities, I don't think, obviously, is going to cause you any trouble to remember. But, so I started with some kind of more complex ones. So, in our first one, it's a compound inequality. So, it's one of those where it's written sort of as a string. Like, you know how sometimes if you're asked for the domain, it says like 3 is less than or equal to x, which is less than 10. In other words, that means that x is between 3 and 10, inclusive of 3, non-inclusive of 10. Okay, so it just really means it's between those two numbers. So in an equation or inequality that we have to solve for x, this expression is between -6 and -3. You're going to isolate x just like you always would. It's just now you don't have both sides of an equation. You've kind of got 3 places where you have to do this. So you're going to add 4 to the right and to the left and the middle, obviously. And you're going to just update it. And then divide both sides, or all 3 places, by a half, which is aka multiplying by 2. So we get -4 is less than or equal to x is less than 2. Do you remember sometimes there's a need to flip the direction of the inequality? Under what circumstances when we're solving do we flip the direction? Go ahead.
When you divide by a negative.
When you divide by a negative, or when you multiply by a negative. That definitely comes up less, but had that coefficient been a -1/2, we would have been multiplying by -2 everywhere. And so it's when you divide or multiply by a negative that you flip the direction of the sign. Okay? So in an inequality, this is going to be similar to equations in that there's going to be a branching event that happens. But let's think logically about this, sort of like we did the other day. If I cover up what's in those absolute value signs, what kinds of numbers would make this statement true? What kind of number could be underneath my finger to make this true? John? Okay, so -20 in and of itself would work, and also +20 in and of itself would work. More than that, though. Right? With inequalities, there's an infinite number of solutions always. So what other numbers? -20, yes. 20, yes. Andrew, give me another number that would work. What kind of number has an absolute value less than or equal to 20? 3. Good. So so far, if I look at a number line, we said 20 would work. We said -20 would work. Andrew just told me 3 would work. What else works? Oops, you didn't see that. Julie, give me another number.
-4.
-4 would work because the absolute value of -4 is 4, and 4 is less than or equal to 20. So -4 would work. So who can give me the range of numbers that's going to work? The span of numbers that's going to work? -20 to 20. Very good. So does that make sense? Anything greater than -20 or less than 20 will work. Has to be both of those things. It has to really be greater than or equal to -20. So when you branch, just like with the equation of absolute values, you keep one exactly the same. So I'm just going to write, and by the way, do you mind if I distribute this first? 3x minus 3 plus 2 is going to turn into 3x minus 1. So when I branch 3x minus 1, I'm going to keep one of these branches exactly the same, not changing a thing. On the other one, I'm going to flip the direction of the sign. 3x minus 1 is greater than or equal to. And what did I say it had to be greater than or equal to? Or what did you say it had to be greater? Negative 20. So on the second branch, you flip the direction of the inequality and you negate the number. And doing both of those things will lead you to the right spot. Okie doke. So you solve each of those, adding 1 to both sides will give you 3x is less than or equal to 21. Dividing by 3 gives you x is less than or equal to 7. And on the other one, add 1, you get 3x is greater than or equal to negative 19. And that gives you x is greater than or equal to negative 19 thirds. Now, when it's a compound inequality, meaning there's more than one inequality, you have to decide if it's an and or an or situation. So think about those numbers on a number line. Being less than 7, that would go that way. And then on the other one, being greater than or equal to negative 6 1/3, which would be, right around there. Being greater than or equal to. Is that an and or an or inequality when you shade in between? And we would say that any solution has to do both of those things. It has to be less than or equal to 7 and greater than or equal to negative 19 thirds. Any questions? Okay, it has to be both those things. If it's just less than 7, let's say it's negative 10. That's less than 7, but that's not going to be a solution because that's, too far below that one. Okay? Or inequalities, just as a reminder, they go in opposite directions. There's really no way to be both. So either your solution is greater than whatever number, or anything that's less than or equal to this number would also be a solution. That's an or inequality. The thing with and inequalities, because they shade in between, oftentimes you'll see the solutions presented the way this inequality was written, like a string of 3 of them. So negative 19 thirds is less than or equal to x, which is less than or equal to 7. Usually that's the way and inequalities are truly written. You won't see the solutions probably written this way. You'd see it written that way. And if you struggle with that, just keep in mind it goes the smallest number, less than the x, less than the bigger number. Okay? Give or take in less than or equal to sign. But you always use less than because you're going smallest to biggest. So this will always be smaller than that, which will be smaller than that. Okay? Number 3. Like the absolute value equations, we first have to get the absolute value all by itself. So we'll subtract 7 thirds. So this will be like 3 thirds minus 7 thirds, which is negative 4 thirds. Now, if we were branching, one of these inequalities would stay exactly the same. Negative 4 thirds is less than x minus 11 thirds. When you branch, you now no longer need an absolute value sign. It's kind of taking care of itself. And then the other one, we'd change this sign to a 4 thirds, and we'd switch the direction of the inequality to greater than. And we'd solve those two individually. I'm not going to solve those, though, because I already know the answer. Think logically about this. What do you know happens to an expression when you take its absolute value? So no matter what x is, when I take the absolute value of this side, it's always going to be what kind of number? Go ahead. What did you say?
Positive.
Positive, right? And isn't a negative number, negative 4 thirds, always going to be less than a positive? So no matter what x is here, all solutions, okay? This has an infinite number of solutions. So you may want to pause once you get the absolute value thing isolated and see if there's an obvious answer. Like, oh, wait a minute, that will always work because an absolute value is always going to be bigger than a negative number. Deal? Number 4 is like a system that you're going to run into on your homework, and it's a little bit different because you're given an equation. That part's fine. The second piece you're given is that y is at most 0, and you're given it kind of verbally. It's not giving you an equation or an inequality in this case written in symbols. What would that look like? If you had to translate that to math symbols, what would you replace the is at most with? Greater than, less than, greater than or equal to, less than or equal to. Think about that for a minute. Bridget, what do you think? Y is at most 0, so y is greater than or equal to 0. Yes? Bridget, I just realized, did I have your sister?
Yeah.
Catherine?
Kathleen.
That was 3 years ago. I was looking at you today. I'm like, geez, she looks like, this girl that I had a few years ago. And then I'm like, oh, yeah, your last name. Okay, I gotcha. So this is what you're going with?
Yeah.
At most. If I say at most 0, can you be greater than 0? No. So unfortunately, with some of the phrases like that, you see most, you're trying to use shortcuts, and you're just going, most means more, I'm going to put a greater than sign. Be careful of that, because the English language is tricky that way. At most actually means less than or equal to. So first things first, with a problem like that, change that into math language. And then from here, it is like a substitution. Since y equals this, I'm going to take this and plug it in for y right there. So what I'm really solving is 2x minus 11 plus, I'm going to distribute that 3 right now. Do you mind? 3x plus 6 is less than or equal to 0. That gives me 5x minus 5 is less than or equal to 0. That gives me 5x is less than or equal to 5. That gives me x is less than or equal to 1. Any questions? I know that you did interval notation last year. I know that you did set builder, but I want to make sure we have the transition between the two of them. So if an interval notation looks like this, obviously with a bracket, that means what on the -4? Julia? Like, what is the bracket versus the parenthesis?
Parenthesis, like, can keep going. Bracket, like, stops it. I don't know how to, like...
I'm not sure if... I don't like the way you described it, I'll say that. But I'm not sure if you're just not finding the right words. Marissa?
Isn't the bracket mean, like, included?
Correct. And the...
Parentheses means it's not included?
Correct. So -4 to 2 on a number line, you'd have a solid circle at -4 and an open circle at 2. You don't need to do that. So set builder notation, because kind of that's including everything between those numbers, would be the set of all x's such that -4 is less than or equal to, and we use that or equal to sign because of the bracket, x, and x is less than 2, and we use a strictly less than symbol there because the 2 has the parenthesis on it. Does that make sense? Again, anytime you're talking about the range between two numbers, we're going to use that notation, which is that string, smallest to biggest. The smallest is less than the x, which is less than the bigger one. And so going backwards here, smallest to biggest, this is -19/3, less than or equal to x, less than or equal to 7. These are both less than or equal to, so I'm using brackets on both. And -19/3 is the smaller number, and 7 is the bigger number. So just taking that backwards. What does number 3 mean? if those are your answers or whatever in interval notation, if you're including all the numbers from negative infinity to infinity, what does that mean? All real numbers, right? So this is the set of all x's such that x is an element of the real number system. X can be any real number if it's between negative infinity and infinity. Number 4 gives us an interval notation, and it's not limited on both sides, see here. It's just x has to be less than or equal to 3. So there is no lower bound, and then we're going to include everything up until 3. Yes? So if there is no lower bound, we use negative infinity as our lower number. Infinities always have parentheses, never brackets. Up until 3, and because it's or equal to 3, we use a bracket on that side. And likewise in number 5, it's kind of unlimited on the positive side, but the lowest we can go is negative 5. So it's the set of all x's such that x is what in comparison to negative 5? Is it greater than or equal to, less than, or less than or equal to? What do you think, Olivia? Greater than or equal to. Very good. And number 6 uses that union symbol. So if your solutions were presented in this way, and I'll throw a number line on here for you, it would mean that your solutions are anything up to negative 3, or up to positive 3, so negative infinity up to 3, not including 3. And that union with, so those are solutions as well as anything from 7, we're including 7 by the way, to infinity. In set builder notation, is this an and or an or type of inequality? Or, yep, when it goes opposite directions, it's an or. So it's the set of all x's such that x is less than 3 or x is greater than or equal to 7. We can avoid writing and because of this string notation, smallest to biggest. There's no way to avoid writing or in set builder. You can avoid writing or in interval notation because you use that u. Good? So back to unions and intersections. Remember, this one means intersection, and this one means the union. So with the intersection of two intervals, you're looking for where they overlap. That's your answer. Wherever they overlap, that's your answer. On this one, your answer is all of those combined. So if I want to look for the solution set to this particular intersection, I have negative 4 up until 0, and both of those would be open circles. And I'm looking for the intersection with that, and from negative 2 up to 1. Both of those are included. So, given that it's an intersection, these two are overlapping from where to where? Bailey?
Negative 2 to 0.
Okay, negative 2 to 0, and what kind of symbol? So I'm going to write that in interval notation. Brackets or parentheses, and where?
Bracket before the negative 2 and then a parenthesis 0.
Perfect. Okay, the negative 2 is still in both. The 0 is not in both. It's only in the top one. It's not in the bottom one. Are we good there? Okay. In the next exercise, negative infinity to 6. We'll just throw 6 there. That's going to be all of that. And its union with 2, close circle, to 9. Close circle. So I'm really not interested in the overlap here because this is the union. I'm interested in anything that is included in either one of the two. So that's everything from negative infinity up until what? Trista. Because I'm given the union, I want to include anything that's included in either or. So that would be negative infinity up until what? Is 7 included in anything? Is it in this set or this set? It is, right? So we should be including it. If it's in either one of them, we've got to include it. So up to 9. Parentheses or brackets, Trista, on the 9? Very good. Are we good there? And on the very last one, 2 to infinity, I'm including 2. And then 4 to infinity. And it's the union. So anything that's included at all should be in my solution set. Sarah, what do you think my solution set should be?
2 to infinity.
2 to infinity, very good. Because guess what? 4 to infinity is a subset of that one anyway. Yes? And so if you're uniting those, you just take the bigger one. So, homework 118 to 120. Anything that ends in a 1 or a 5. Any questions?